us begin today's session. So, good evening, everyone, and welcome for week 8 live session for Advanced Research Trends in Smart Grid Technologies. I'm Gagan Meena, and I'm TA for the live session for this course, and I'm currently doing PhD in Electrical Engineering Department from IIT. So this will be the agenda for today's live session, and we have followed this in the previous sessions as well. So if you have any suggestion, you can always tell me regarding the conduct of these sessions. So first of all, we will go through a very brief overview of week 8, and then we will discuss some questions and also discuss some important points regarding those questions. And then finally, we'll take your doubts. And if you have any doubts, you can ask in between also. So shall we continue then? Is it okay if we go in this way? Okay. Just to remind you that assignment for deadline for assignment 9 and 10 are March 22nd and April 5th respectively. So just submit the assignments on time. And also you can watch the recording sessions using this link, which is also available on the portal. So let us begin with the overview for week 8. In week 8, we discussed these 5 topics. We started with optimal PMU placement. Then we discussed some concepts regarding cybersecurity and cyber resilience. Then virtual inertia and ancillary support. And finally, demand-side management and smart. And one of those techniques of ensuring demand-side management is demand response. So can anyone of you tell why do we need to go for optimal PMU placement? Why don't we just put PMUs on each and every bus? Anyone? Do you recall what was discussed in the class? Basically, our main aim is to ensure the reliable operation of power system, and for that we need to ensure that we have a generation and load balance all the time. And to ensuring that we have to monitor the power system on a real-time basis. For monitoring of the system, we require data. This data we get from these PMUs. However, the PMUs they are not so economical, they are costly. But we also want to monitor some critical buses or generators or lines. So we need to install a minimum number of PMUs so that we can get the entire picture of the power system, which we call it observability. So our goal in this optimal PMU placement problem is to find the minimum number of PMUs required to such that the overall cost of PMU installation is minimum, subject to complete observability of the power system, and also different power system constraints. So yeah, this is the same which I just told right now. So because of increase in uncertainty, we want to have real-time monitoring of our system for state estimation, and same thing. So we want to place PMUs at optimal bus location so that all data can be received to ensure the real-time operation. So this is the problem formulation for optimal PMU placement. So where the objective is to minimize the total PMU installation cost. So objective function is to minimize the installation cost, which is this. So this is the cost for each PMU multiplied by this variable xi, which is a binary variable, which can take either 0 or 1 value. So if it is 1, the objective function will have the associated cost of PMU in the function. And so if suppose we have 5 PMUs, suppose number of buses are 7, so I will vary from 1 to 7, and xi will be 0 or 1, so we'll be having x1 to x7 values. So this objective function will be having this value CMU, considering that you can also write this as CMU PI, so that the cost is same for each PMU considering that. So this will be x1 plus x2 up to x7. So now with respect to this objective function, we have to satisfy this constraint also. So while satisfying the constraint, we will get a solution such that some of these value will be 0 or all of them may be 1. So if all of them are 1, that means we need PMUs at all the buses. If suppose one solution is such that x1, x2 and x5 are 1, but others are 0, that means out of 7 buses we will place PMU at only 3 buses. So these are the different constraint which needs to be satisfied, and this is the observability constraint. Is there any doubt up to this point, or shall we move ahead? I hope I am audible. Okay, then, so let us move forward then. The next topic which we discussed was the cyber physical system, so which is a combination of two things: cyber and this physical system. So before the concept of smart grid, we were having, our conventional power system was having only this physical system. So this is the basic structure of a cyber physical system. So this layer is this is the cyber part, and this is the physical part where we have different plants. You can say generator, transmission lines, circuit breakers, relays, and they have actuators and sensors. So these physical system will send some information to the control center via a communication channel. Via a communication channel, so we can send this information to a control center where we can process the information. Because this data which we send is in analog domain, so we first convert it into digital domain. So whatever processing that we do nowadays is in digital domain. So we'll first convert the analog into digital. Then we will process the data and generate some control signals. So since this is the output is also in digital domain, but the actual physical process or plant, it works with analog output. So we have to again convert the digital into analog. So the control signal here will be going to the plant via the communication channel. The same thing is shown here also. So this is our physical system which is consisting of our plant. Suppose this is a generator. So it will be having sensors and actuators. Sensors will be sensing different quantities that we want to control, and they will be sending the data via communication channel to the control center, which will then process the data and send it back to the generator via these actuators. So these actuator will help in controlling the function. It may be your governor. So when there is a frequency deviation between two areas in a system, so the control center, when senses that the deviation is more than the threshold, then it will sense a signal and then it will go to the actuator. So here the actuator will be governor or the steam valve, so it will open or close in that accordingly based upon the generated error signal. So this cyber part has all these components. This communication system, protocols, and then computational tools, and then control system, including IEDs and different types of IoT devices. So is it okay? Yeah, so these are to differentiate between these two systems. These are different characteristics. So we can see starting with the component. So in physical system, components are same as those which we have in conventional power system and in smart grid. Both the physical layer has the generator, transformers, line, circuit breaker, relays, load, etc. And then in cyber system, as we have discussed, control system, communication, and computing devices. And this system, physical system, works in continuous domain. Also, therefore, it is analog. Signals are analog. While the cyber system works in discrete domain. So here, modeling that we do we remember the transmission line modeling, power system dynamics, all that modeling that we do is in differential. Those are differential equations. So all these are differential algebraic equations. But here we have to, because it is in discrete domain, we have to work with the difference equations. So here there is a flow of energy and here flow of information. Similarly, all these, so here type of contingency will involve any kind of outage or fault. So generator load outage. There can be line fault, different type of faults. These are the contingency for the physical system, while for the cyber system, contingency can be cyber attack. If you have any question in assignment 8, you can ask. You can discuss in the question also. So here we have contingencies such as cyber attack, communication latency, or even missing data. So these are the comparison between the two types of systems that we have right these days. So these are the advantages of, I think we all have gone through lectures first. This just for a quick recap so that you can recall everything, so that when we discuss the questions, you can easily answer those questions. And also you can refer to these slides when you prepare for your exams. These are just a summary form of all the lectures. So these are the advantages. We have two-way flow of information. Everything is automated, flexible control, and secure operation. However, the main problems with this cyber physical system is this: they are prone to cyber attacks at different levels. Also, there are communication latencies, or we can call them delays. Delay in information received. So package dropouts, there can be some missing data. Then there can be congestion in the network. It's always possible. And then malicious control effects, some human error may be also be there. Any spurious signal. So cyber attacks can be of these different types. There are two main categories. One is this FDIA. So can anyone of you tell the full form of FDIA? And DOS? Anyone? So this is false data injection attack. This is denial of service attack. So it's clear from the name also that what is a false data injection. So instead of the desired data, the attacker is manipulating the data and injecting a false data, changing the data. And then the controller or the control center receives a bad data. Or it can be that if the attackers changes the entire data, then it can lead to maloperation of different power system components, and that can be hazardous for the grid. Because unless we receive the correct data about the different states about the different measurements that we have taken from PMU, we cannot identify the state of the power system accurately. So this is one of the biggest challenge. So one of these is GPS spoofing attack. So one can play with this. You know that PMU works with the help of GPS. The time synchronization that is done is because of this GPS, Universal Time Clock UTC. So because PMU works with this GPS signal and the UTC, the time synchronization can be lost if the attacker injects a false data. There are several types of techniques to detect these false data that we will see. I think you know also. Centralized versus decentralized techniques are there. So this false data injection can happen at these three levels, either at sensor level or in the controller. So data from the sensor can be manipulated, or the controller action or the error signal generated, control signal generated by the controller may be manipulated, or the error signal which is input to the controller that may be manipulated. Then the communication links may be manipulated. So these are the three vulnerable areas where this fault data can be injected. So, Jay, do you remember what is MITM?
Please repeat.
Do you remember this full form of MITM? Under one of these is under denial of service attack. There are two type of attacks. So one is to suspend the communication itself, and other is MITM. What is the full form of MITM?
Full form, not remembering, but they can change the system parameter, working parameters. Suppose power demand is not, the frequency will change. Load. Those, I think that sort of things. We are changing our control parameters.
Here also we are changing that. FT. Here also we are injecting false data, but here we are doing something else.
Not remembering now. Please. Please repeat.
Anyone else? Can you recall? Any of you? Adarsh, do you remember? So MITM is man in the middle. So what is happening? There is one sender, and so we can say control center, and here is your physical system. So they are there is a two-way communication between these two via the communication channel. But in between the communication channel, so this direct communication between them is interrupted and something else is incorporated here. Suppose it is similar to something like if you are opening your browser and then you are entering suppose your institute internet link which runs the internet services in the institute. You are opening that and it takes you to the authentication page where you have to enter your details, Wi-Fi details. But you are entering those details thinking that it's the Wi-Fi page, but actually behind that it is something else. So it actually takes you to a different site, to a different computer. So that is this man in the middle. So there is another computer interface in between the two, which can interrupt the communication between the two. So it can be unidirectional and bidirectional both. So in between, the attacker is sitting in between, and here is control center, here is power system distribution network. So we are getting control signal from here to here, and we are sending some information from here to here. So this attacker can influence both of them, either one of them or both. Is it okay? So suppose for FD is fault data injection, if we consider that before the normal situation was that load was okay. So load was 100 gigawatt and generation was also 100 gigawatt, and frequency was balanced at nominal frequency 50 hertz. Next instant also there was only a slight increase in the load. Okay, and generation is same. So this will not result much deviation in frequency. So suppose it is 49.99 because load is more, so frequency will drop. But instead of this information, the attacker, what is saying, it is changing it to 101 gigawatt or even more. So there will be a huge drop in frequency. Although the actual load is this much, but the control signal, this information will go to the control center, and the control center will issue a signal to increase the frequency, and the frequency may go beyond that limit. So that will be a problem for the grid. So these type of things can happen because of false data injection, or the data of false injection can be there in the economic dispatch. So a generator was to be scheduled for 100 gigawatt, but the attacker changes this value to 90. So if this happens, there will be a 100 megawatt. So there will be a deficiency of 10 megawatt. It will not be known to the control center. So that will again result in a generation load imbalance mismatch. So all these kind of things can happen. So to maintain a system which ensures that these things do not happen, so that will be cybersecurity. So there are these two terms like security, which is to protect against these kind of disturbances and avoiding any kind of threat. Then we have resiliency. So if anything, so in resiliency there are three parts. One is physical resilience, which we were focusing in the conventional power system. Then we have cyber resilience. So in physical resilience, we think. So resilience mainly is, if we consider any conventional power system also, suppose there is a huge, big fault, a short line, three-phase voltage fault, and there is a lot of generation is out from the system. So how do we quickly restore the system, and how do we isolate this system so that the disturbance do not transfer to the entire system? So how quickly we can do that? That will be part of resilience. If we are able to still manage the system after the disturbance, during the disturbance, very quickly, reliable, and still able to operate the system, then it will be a resilient system. Suppose, especially this concept is now coming up because especially in United States and European countries, because US every year there are so many hurricanes. Because of hurricanes, there is a lot of disturbance, and so many lines are out because of high speed of winds. Lines are taken out, or they may be even damaged. So load are not able. So generators are not able to supply the load. So how quickly we are able to ensure a supply to those loads, and also how to isolate the affected part of US from the grid. So all these part will come under this resilience. So similarly, we are talking about cyber resilience. So there are three components. First, you want to mitigate the damage, and then although damage is there, still we want to carry on the system, and then also we want to isolate the compromised part. So if you are able to do all this, then we can say our system is cyber resilient. Similarly, this can also have same thing applies to communication also. So these three, we want all the resiliency of power system at these three levels: physical level, cyber level, as well as the communication level. So is it okay? Is there any doubt up to this point? Yes. So let us move on. So these are just we were talking about if there is cyber attack, how to detect those. So these are the different techniques. These are the centralized techniques. I think you would have heard of this chi-square test. When we do state estimation, we use this test. Then there is another test, this residual phase, or we also call it largest normalized residual test. So the data which has the largest normalized residue, that is removed. So that corresponds to bad data. So that is removed from the entire set of data. Similarly, there are techniques of using machine learning and statistics. Then we have these decentralized techniques, out of which this singular value decomposition is a very popular one. It also gives information about the incomplete measurements. Decentralized ones. I think there was one question in the assignment also regarding which of these is not a centralized or decentralized detection technique. So after this, we went discuss the virtual inertia concept. So who can recall what is virtual inertia and why do we need actually? Most important question is why do we need virtual inertia? That is the important question. If you are able to understand that, then the concept will be clear. So can anyone tell? Dipin, can you tell? Jay, do you remember?
Virtual inertia, you can say in normal thermal power generations, our generators are having enough load margin, and you can say in case of any disturbances, they can come up in a very short time based on frequencies changes. But if we are adding more and more renewables, so that probability is reducing. So some system has to be developed that can be taken care. That system can be obtained by different means. So the concept is virtual inertia is the sudden to take care of such a change in load conditions. We should have enough control over that. That is the,
So you were saying that conventional synchronous generators are able to respond quickly.
yes.
Yeah. So, but main thing is, how are they able to respond quickly? So what is that thing which makes them enable them to do this? To arrest the frequency change, increase or decrease in frequency change. How are they able to do that? Means decrease in frequency change. What is that which differentiates them from these renewables, inverter-based renewables? That is this inertia, right? Because the conventional synchronous generator are rotating mass.
Yes.
So they have inherent inertia because of the stored kinetic energy.
Yes.
So when there is a sudden slight increase in the load, because of their stored kinetic energy, they can supply to some extent. If still that frequency is not within the band, or still it is more, the deviation is more, then we have to open the valve, the steam valve. So that will be the governor action will come into picture.
Yeah.
And even after doing that also, we are not able to arrest the frequency, then we have the AGC will come into picture, which takes care of the imbalance between different areas. So this is a series of operations that will happen. So which starts with this inertia. Because of this stored energy in the synchronous generator, the rotating mass, we are able to get that feature. But in this inverter-based DGs, we were not able to do that because they don't have rotating mass. Wind does have that, but this still it is interfaced with inverter. So we have to modify the control techniques. But PV storage fuel cell, they don't have any rotating mass. So we have to mimic that inertia property of synchronous generator so that they can also provide that kind of facility. So that feature of mimicking the inertia concept of synchronous generators or diesel gas turbines, that is the concept of virtual inertia. So it enables a converter in hybrids to mimic the behavior of conventional generators. So this is only for the inertia part. So by suitably modifying the control techniques, we can insert a virtual inertia. However, if we are also able to make them behave like a synchronous generator, entirely like a synchronous generator, then they can also provide other services, voltage support and frequency support services. And the benefit of these type of virtual synchronous generator is that we can make any adjustment online from the control center via communication channel. So that is the advantage. And we need this because as the penetration of renewables increases, this thing will be required more and more. Although they provide this facility, but still, if we substitute a synchronous generator with the equivalent amount of renewable, the flexibility provided by the two will not be equal. Synchronous generators are still superior in providing this inertia support. Still, we can do something. So this is the All India demand met, which I have taken from this Osoko monthly report. This is for February. So this is for 17th Feb. So on 17th Feb, in the month of February was the highest demand. So now we are moving to the demand side management part. So what is the objective? Why do we want to do the demand side management? So that we want to know. So here we can see, here we have one peak. If we consider it like this, we can also say there are two peaks. This is only for February. Sometimes we also have demand. I think it's there on the next slide. So sometimes we have evening peak also in our Indian profile.
Last year it had touched 200 megawatt also, 200 gigawatt also.
Yeah, this year also in January, the highest peak demand met was around 211 gigawatt. Yeah. So it's increasing. Here also we can see it's almost around 210 gigawatt. So it's increasing every year, and this gap between this peak and this drought, if this is more, then this is a problem for the utility, because yes. We see that if this curve is like this, always ideal case, this is ideal, then we have to design our installed capacity as per 140, or we can say plus minus 1% something, 5%, and we will be sure that will be able to meet the demand always. And also that generation will be effectively utilized, because it is almost always running near its full capacity. So that will be the most effective utilization of the installed generation capacity. But if the scenario is of this kind, so here we can see only for this period, these generator which are providing demand for this duration, they are operating only for this period, and that too they are only providing this together only 40 gigawatt out of 200. So these generators are not effectively utilized. They are only used for some during few hours of the entire day. On the other hand, the generator which provide this, which is also called base load generators, so they are working with a good efficiency. Their utilization factor is high. And so for such kind of a car, we need to have a higher installed capacity. Here we can see it is the peak is 210 gigawatt, but do you know what is the installed capacity in India?
In thermal or in all?
Overall.
More than 800.
No, it's not 800. 800 it will be too much.
Including all renewable and all.
800, it's not 800. It's around 435 gigawatts. So we can say it's almost double our peak right at present. But this is the installed capacity, out of which this is not always available, because some of the generators around, they will be on maintenance. They have their scheduled maintenance. Sometimes there are forced outages also. there may be some fault or something. So not this for entire 435 gigawatt is available. Also considering this, that around 100 gigawatt is solar and wind may not be available all the time. That is also, then also we can say the at a particular point of time 435 is not always available, and all of them are not always scheduled also. Here we can see in this third graph, the solar is available only, the peak solar is available only this time, during this time, around 10 to this, you can say this 10 to 3 p.m. And wind is available here. So there is a clear mismatch between the peak demand, and although in February we can say the peak demand is here and peak solar is here, so they are also not coinciding. So peak wind, peak solar and peak load all are occurring at different times. So as the renewable increases, this challenge will increase further. So that is why we are talking so much about storage. So these are the different, we have 5 regional grids. So these are for all the 5 regions. So here we can see this graph. So this is the sequence of operation which happens on the, this is the time scale. So whenever there is a small deviation, the inertia will come into picture. Its response is few cycles, 1 or 2 cycles. Then primary will come into picture if inertia is not able to do. Within 2 to 5 seconds, it can respond. Then secondary has to come if it is not able to do. Around 15 minutes, up to 15 minutes. Then fast tertiary and slow tertiary. So these are the sequence of frequency control operations that we do. So this is the curve which I was talking about. So this is one of the typical load curve. Also this is for 2016 year, because last annual report is available only for 2016. So this is this curve is for month of February. But if we see the typical curve for a year in India, then we have this evening peak, especially during summers you will find this. In winters we also have morning peak also, because of heating requirement. So these are this. So this is called night lean. This is day lean. So in day we have this drop in demand. Then this is the morning peak, especially in winters. This is there, and then this is evening peak. So this is a characteristic profile for India. And so the objective of demand side management is to maximize the use of renewable energy resources, then to maximize the economic impact, benefits, and to minimize the power imported from the main grid. So the distribution network is connected to the main grid. So if we take less power from the main grid, we can minimize the transmission losses, because we are generating power locally using these renewable energy resources. Because each distribution company or distribution system has to buy some generation to meet the demand. But if we are able to reduce that dependence, we can ensure a reliable supply to our consumers. And the main goal is to reduce the peak load demand, so that there is a effective utilization of all the assets. So this can be done. This is ensuring this is also an optimization problem. So how much should be the installed capacity to ensure this kind of characteristics. So it can be made it can be of two types: objective problems, optimization problem. One is single objective, second is multiple objective. So do you remember what is single objective and multiple objective? Pranjal, do you remember? So in single objective, so we want to meet the demand curve as close as possible. In single objective, this can be done either by maximizing benefit to the utility, and another is consumer. So if the optimization problem is only focusing on either one of the two, either it maximizes benefit for the utility or for the consumer, then it is a single objective. If both of them are, if the benefits for both of them are maximized, then it becomes a multiple objective. Okay. So this is a summary of the last two lectures on demand side management and demand response. So this is a very important slide. You can also refer this. So demand side management, it's a technique where we want to reduce the peak load. So we also call it as a non-network solution. So it's a non-network solution to reduce the peak demand. And it has three types of strategies. So one is the energy efficiency. So this can be done by replacing the less efficient equipments with more efficient equipment, such as 5-star rating equipments, or what we have done in India, the LED program. We have replaced all the incandescent and the CFL bulbs with these LED bulbs. Nowadays, we also have these BLDC based fans. They are very efficient. They only consume 28 watt, while the induction motor based fan, they consume more than 50. Some of them consume even 70 watt. So 50, 70. But BLDC only consume 28. So if we replace those, so suppose if it is 70, so we are replacing one fan. By replacing this, we can use two fans. So that can help consumer in reducing their bill also, and it will help utility because the demand is also reducing. So that is done through the energy efficiency. So in this, we are not changing the behavior of the consumer. We are only changing the equipments. The consumer is still using the fan. Consumer is still using all the equipments, but it is using a more efficient equipment in place of the inefficient. While the second approach is the energy conservation approach, where we want to change the behavior of the consumer. For example, when we go out of the class, we switch off all the lights, AC. If no one is there in the class and AC is still on, so no one is getting benefited. If we can make these slight changes, so we can conserve energy. So this is one example. We can do such things. For example, one good example is that in summers all of us use AC. If we just increase the temperature of AC by 1 degree Celsius, it has a lot of impact on the energy consumption. the temperature versus the energy consumption in AC is not linearly dependent. So it has a huge impact. Even 1 degree Celsius difference make a lot of difference in the energy consumption. So that is a part of. So here we are changing the behavior of the consumer by motivating them to change their habits so that we can conserve the energy and reduce the required energy. Then we move to the demand response, which is the last topic. The demand response can also be divided into these based upon different types of categories. One category is based upon the control strategy. Here we have two categories. One is the centralized and other is the decentralized. So in centralized, the entire decision is taken by the DSO, distribution system operator. But in the decentralized, the DSO will provide a pricing signal, and so they will provide this information to the consumer prior to the actual time. Suppose tomorrow the DSO Today, the DSO provides the information of the price of electricity for tomorrow. So let us say the DSO provides this information to us, that this will be the price for the tomorrow for the entire day. So for these duration, we see there is a high price. So because consumer know that tomorrow during these 2 periods the price will be high. So I can reduce my consumption during these 2 time periods and consume more during the other time period. So in this case, the user will schedule its load on its own depending upon the received price signal. So the utility will only know about the net consumption of the consumer in this case. While here in centralized, so overall load profile improvement is done by considering the network security. It's a global outcome. Global goal is taken care here. So the here main thing is to see that the network is secure. So the consumer's benefit is not considered here in that one sense. While decentralized one is better. So consumer can do that. They have their choice. So is it okay? Any doubt in this? Jay, is there any doubt?
How is spot market? We have heard they are purchasing from energy exchanges on the spot market.
Who is purchasing?
In which, like a grid, and nowadays a new term has come. Energy exchanges has come.
Yeah, energy exchanges are there. So we have 3 power exchanges in India. So
yeah.
One is IEX, another is PXIL, and the new one is this HP. That is Hindustan Power Exchange Limited. So
they are purchasing on spot basis also. Spot prices are there also.
So they are not. These power exchanges do not purchase. They provide the platform for buyers and sellers to come together and then discover a price. So they will facilitate that interaction between buyer and supplier. So they will have a online platform portal where buyer can bid their requirement, even and the supplier, the generators, they can also bid. Then they will run some algorithm and they will come out with a common price, which will be given to all the generators, will be given that price. So here we can see like this. Suppose these are the demand bids. So those who, the distribution company who want the load to be met at any cost, they will be ready to pay as high as possible. Correct? Is it okay?
Yeah, okay.
Yes. Similarly,
So
yes.
my question are whether they are part of centralized or decentralized way, because price is not known. No?
So here we are not controlling anything. This is a general procedure. This will not come in demand response.
Okay. So one, they are also a DSO, means distribution companies. They
Yes,
are
yes,
purchasing from some generating
yes.
company.
Correct.
Exchanges is an intermediate media, you can say, like two
Correct.
media, you can say one agent in between them.
Yes.
So, but, my question is that how can we will predict next day my cost will be like this? So they will can send to their consumers in this decentralized way that during this period my tariff will be this. Uh, uh, yeah,
Actually,
my
what
question
happens
was
for next day, we have to bid one day before. So that is a day ahead market. Another market is a real time market. That is 15 minutes before. So we have in India what we have 24 hours. We divide each hour into 4 slots. So 15-minute block. So there are total 96 slots or 96 blocks. For each block, generator as well as the distribution companies will bid one day before in the day ahead market and 15 minutes before in the real time market.
no. Okay. Well, it is nothing related to this centralized or decentralized way.
No.
Not linked anywhere.
Not directly linked.
Okay. Okay, please proceed.
In decentralized, we are saying that yes, we make the consumers know that based upon the demand which they forecast, DSO forecast a demand, based upon that they will bid in the market. Because they don't know the actual demand, they just do forecast. Then even if after that forecast goes wrong, the real time market is there to purchase the balance amount. Even if in that market we are not able to get the demand, then we have to curtail the load. We don't have any option. If we don't have sufficient generation in our in the distribution network itself, then the load will have to be curtailed. So based upon the forecast and the day ahead market cleared, they may provide a signal to, suppose the distribution company knows that based upon the day ahead market, they already know that next day I will be able to supply this much load, and they are already short of the actual load which they have forecasted. So based upon the day ahead market price, they will say that they will make the consumer this information available that tomorrow the price will be this based upon forecast, because they already know in day ahead market this has been cleared, and also based upon the historical data they know that the real time market price will be this much. So if they want to still consume, so they have to pay this much, and if consumer are ready, then the distribution company can purchase. But to motivate consumer to shift to other, we are giving this price signal, and if they respond, then the approach is successful. We will be able to reduce the demand, peak demand. So they have a monetary benefit in shifting to the other time periods.
Okay, please proceed.
So this is based upon the actual control only. So decentralized will also come here. This is also a type of decentralized one. price based. What we were talking now, that is this price based only. So in price based we have these two options: dynamic price based and the incentive or penalty based. So in dynamic price based we can have time of use tariff. So based upon time of the day we can utility can decide the price. So for some hour, if the price is, so it will be generally following the load curve only. So if for some hours the price is more, so consumer will shift here. So the demand can be reduced. Another is this peak load pricing. So in peak load pricing, this will happen. There are two price levels. One is for this peak load and one is for the off peak load. So for peak load, there will be a high price. So consumer, because they know that during this period the price will be high, so they can shift to the other hours. Similarly, this critical peak pricing, it also has, so suppose this is the peak hour duration. So normal off peak hour the price will be less. Peak hour period also they will divide into some more periods. So they may say that this is the critical peak. This is also a peak, but during this period they will make a very high price. And during the rest of the peak demand period, the price will be relatively low, but still it will be more than the off-peak hours. Then the real-time pricing is, it is based upon the 15-minute block. For each block, the price is changing. So that is not done right now anywhere, but it can be done. Although it will require a lot of efforts, lot of changes to be made. And we have this incentive based and penalty based. Here the utility will make a contract with the consumers that if they reduce the demand, then they will be given some incentives. And if they are not able to do so, they will be penalized as per the contract. Especially in these two. This is a bidding where demand can also bid. The consumers can bid. This can be done through aggregators. Then the third category is the load based. Here also there are two options. One is task related, one is energy related. Says here task related, what is happening? The consumption is not changed. Only the operation, the consumption time is adjusted to reduce the to ensure that the time does not coincide with the peak demand. But in energy related, here we try to reduce the consumption during the peak demand. Although the operation time of the load is same. So suppose that this is a load profile and this is a peak time. So this energy related method will reduce this demand itself. So overall energy consumption of that load will reduce. But in task related, what will happen? This area will remain same. Only this part will shift to some other part, either before few hours or later, few hours after the peak load duration. So is it clear? Yeah, do you have any doubt?
Task based and energy related. Please repeat again. There is some.
So in energy related, so task related is that Suppose a total energy consumption of load is 10 kilowatt hour, and this is the load profile of the load. So this is the peak load, and it also coincide with the actual utility, the generation peak also. So overall peak of the utility also coincides with the load peak. And since we want to reduce the peak demand, so in task related, this area will not be changed. Only this part will be shifted either here or here, so that the overall area remains same. So the total energy consumption will still be 10 kilowatt hour, but the time of consuming this peak demand, that will change. So from between T1 to T2, it may change to T3 to T4. But overall consumption in the day will be 10 kilowatt hour for the task related. But for energy related, the energy consumption itself will be reduced. So this peak during this time, the load will be reduced. So this curve will become like this. So here the area under the curve is all changed. The total consumption will be less than 10 kilowatt hour here, although the time of consumption here remains same. So in here in task related, this load is flexible with the operation of time with operational time, but the load doesn't want to reduce its consumption. But in energy related, the load it wants to consume at the same time, but it is flexible in reducing its consumption. So that is the difference. Is it clear now?
That's clear. Like, who controls both the things? Task related and whether consumer controls or DSO controls this.
So consumer has to tell that. Consumer has to be, if consume, there are some flexible loads. So DSO will have information about these loads. So they can also have a contract with them. Or based upon the historical data, they have this data. So that these loads are flexible.
It means they will go for load shedding also?
Yeah, here what is happening that here the consumer itself is reducing its demand here. Or if consumer is not able to do, then the DSO will reduce.
Yeah.
Yes.
If consumer is not reducing, then DSO will act, no?
Yes.
Okay. Okay, clear. Please go ahead.
But here, yes. So this is based upon the load, type of the load. So this is a more flexible load, we can say, task related. Okay. Now let us move to questions. So based upon what we have discussed till now, all the questions have been framed. So I think you'll be able to do them. So first is, which of the following statements are correct with regards to optimal PMU placement in the distribution grid? First is economical. An observability constraint is an essential part of the problem formulation. C is PSO is one of the classical optimization techniques. And D, optimal minimum number of PMU for IEEE 1181 system is 30. So which one is correct? Okay. What do you think?
T optimal number of PMU for IEEE 118 system is 30.
It's not 30.
Not correct.
What do you think about other options? Are they not? Are they incorrect? So first one is. What do you think about first one?
It's not highly economical.
Yeah, if it was economical, then we would not go for optimization.
It's not highly economical.
So this is incorrect. And what about this B?
Yes. Constant is essential for. Seem to be correct.
Yeah, this is correct because we want the problem is such that we want minimum number of PMUs.
Yeah.
Such that this entire system is observable. So this is correct. And C, PSO is it a classical optimization technique? Let us see here. So these are the different optimization techniques. Okay.
Binary MLFP Prof best.
So this PSO is it? So in classical we have this binary LP. All the variables are binary. Then MILP here, at least one of the variable is integer. Then this is non-linear programming. So all these are classical methods. But these are genetic algorithm based PSO. These are nature inspired optimization techniques. They are also called materialistic techniques. So PSO is not a classical technique, right?
Yes.
Let us see. So, oh, this I have to change this. Color this should not be. This is the color. Sorry for this. I'll change this. So this is next question. Which of the following is correct with regards to cyber physical system? So we saw this one, right? C1, C. MITM. MITM falls under category of FDIA. Is it correct?
No.
So what type of attack is this? It is denial of service attack, right?
Yeah, denial.
So what is the question? Which is correct? So this is not correct. So now let us see the B option. Communication latency is a major advantage of cyber physical system. Is it true?
Yes, sir. Latency. Yes, it's true.
How? Latency means?
Latency means delay, na?
So will delay be
No.
an advantage?
It will give you the advantage. Yeah. Something delay happens, then
No, we don't want.
they will not be able to do. No, it's not correct.
Yes, this is not an advantage. This is a disadvantage.
Latency means.
So any kind of communication delay or
Yes.
attack or malicious information or congestion in the network. All this we don't want.
Yes.
All these are disadvantages. So this is also a disadvantage. Now let us check option A. Option A, actuators and sensor are a part of cyber layer. Is it correct?
Part of cyber layer.
So in cyber physical system we have two parts. One is cyber and one is physical system.
Yes.
So this physical system is interacting with the cyber parts.
Will be the part, na? Because both are the part.
No. We have to see that actuator and sensors are part of which layer? Cyber layer or physical layer? Suppose this is
Part of
Here we have a generator.
No, physical. The physical.
Correct. Because in cyber layer we are having this.
Yeah.
Communication plus computation plus control.
Yes.
Here we are having the actuator and sensor. Physical system is having these two. Actuator, sensor are sensing the data, sending the information to the control center via the communication channel. Then communication channel goes and communication control center is processing that information, sending it back to the physical system in the form of control signals. Correct? Also incorrect. So what about this? Running the most up-to-date firmware firewall is one of the ways to ensure cybersecurity. Is it correct? Is it correct? Can you hear me?
Which one?
D, option D.
Option running. Stop put it firmware. Firewall software is one of the way to ensure. Yeah. We are update. We are only asking for updates.
Right. So this is the correct option D. So let us move to the next question then. So this is the next one. Which of the following is there are limitation of demand response for frequency support? So which of these are limitation of demand response in providing frequency support services? Can you answer this?
D is correct. 4 major ancillary services cannot be provided simultaneously.
This is so. So this is a limitation. What about others? Are these also limitations or not? This is correct. This is one of the limitations. 4 services cannot be provided
Simultaneously.
So what about first? What are the 4 services? Can you tell what are the 4 services? Do you remember?
Voltage, frequency. These are
voltage. One is voltage support. Another is frequency support.
Frequency support.
Other 2.
Third will be the power.
We can say system strength.
Systems.
So fault right through. Then last one is this inertia support.
Yeah. Last one
this is the first, the second part. So these are the 4. So we can provide simultaneously. We cannot provide. Okay. So then first is it a limitation? Unpredictable demand response. We don't know the demand, especially when the EVs will charging and discharging of EV, that is also unpredictable. Anytime EV can be charged.
Yes.
So this is also a limitation.
Yeah.
Then what about B?
Yeah, complexity also involved in communication.
Correct. Sort of communication is.
Yeah.
Infrastructure will be required. Then this is also we discussed, right? That the renewable inverter based DJs cannot provide the same level of flexibility compared to their conventional counterparts. So they will always provide less flexibility than the conventional generators. So which option is correct? This is correct. All of the above.
All of.
Now this is the next question. This you should be able to do. We have discussed this several times. Select the correct option with respect to frequency support services. Option A, tertiary frequency response is based on governor action. So is it correct?
The secondary frequency. Corner exercise is based on secondary.
No, not secondary.
First, minor variation. Okay.
Minor
First
variation.
minus, then inertia will come.
Yes. For minor, inertia is there.
Yeah.
After that,
primary will come.
So it is based upon this.
Governor
Secondary. Yes.
Governor will come in primary phase.
Yes.
Yeah. Inertia, then primary, then.
It is based upon AGC. Secondary.
Yeah. AGC.
Then tertiary is last. So option A is correct or incorrect?
Not incorrect. No?
Right. So what would be? If there are two areas interconnected by a line and there is a frequency deviation, can it result to load shedding?
Yeah, definitely. If they go beyond the limits, then.
What about third? Energy storage cannot provide frequency support services.
Energy storage. Cannot provide. Now, indirect way it will provide. Now, indirect, suppose it is managing load response, then frequency will also get stabilized. Now, indirect way.
Yes, storage can provide all the four type of services, all these four.
Yeah.
So this is incorrect. It can provide. And last, response time for primary frequency services is within 2 cycles.
Primary frequency services.
Yes.
Not remembering. 2 cycles means very
40 milliseconds.
fast.
Yes. Yeah. It's very fast.
Very fast.
Can it be so fast?
Primary frequency services.
It is based upon governor action. Governor is a mechanical.
Yeah, governor cannot.
Can it operate within 40
No. Governor cannot. Any mechanical device cannot within 40 milliseconds.
So let us see these different frequencies approach. So these are also called these essential reliability support services. So we want to ensure frequency within the acceptable band. First is the inertial support.
Yes.
It is based upon the stored rotating energy. And this is inherent in the conventional generators, so that helps to arrest frequency decline. But it can also be provided by these renewable generators by suitable modification in the control algorithm. And it is the response time is within cycles, order of cycles. So do we require a communication system for this? This is automatic, right? We don't need any communication system here. Then comes the primary. It is automatic and autonomous for each generator based upon this true and governor response. Based upon the governor response. This can also be done by renewables by changing the control. And the response time is this within 2 to 5 seconds.
5 seconds.
Yes. So that is where that option was not correct. Then comes the second trick. This is to minimize the area power mismatch. This is centralized through AGC. And it requires significant bidirectional communication between the generator and the control center. And the time of operation is this 30 seconds to 30 minutes. Then finally is the fourth level is the tertiary. Here the spinning or non-spinning reserve can provide this. This is not automatic and the time of response is 15 minutes. It can operate within 15 minutes. The energy storage can provide all these four services. So this one is correct. D. Let us move to the next question then. So next is this. Which of the following is not an aim of demand response analysis? I think this is very easy question. You have to answer this question. Suman, can you answer this question? C, correct. C is correct. So what do you think, Jena? Is C correct option?
Question is not, na? Question is negative.
Yes.
So, not. Yeah, then correct. C is.
We don't want to promote conventional generation. For the last so many years, we want green and clean energy. We want DERs, local generation from PV and wind. So this is also true. We want aim is to minimize the total consumption to reduce the peak demand, so that we can flatten the load curve. This type of load curve we want to make this. Then reduction of total required power generation. This is also different. This is also true. On the whole, we want to reduce the installed capacity. If without increasing, not reducing, if without increasing the installed capacity, we can still meet the demand, then that is a good idea. Similarly, elimination of the line overloading. So if we can generate locally, this is the main grid and this is the distribution grid. And in between here we have these transmission lines, and if we are able to generate locally here by PV or wind, then we don't need power from here. So the transmission line overloading will reduce. It will not be overloaded. It is, yeah. So these are the different teams, and so this is correct. This we have discussed. All these are covered, and these are the different optimization objective for the demand response analysis. So we want to minimize the cost of electricity. We want to maximize the social welfare. So do you know what is social welfare? Jay, do you know?
Optimism.
Maximization of social welfare. So what is social welfare? Any idea? Non-profit win-win situation for all. Yes, win-win situation for both the discoms and generators. So we can see here, just I was drawing this picture in last slide also. So suppose this is the demand curve for the discoms. Okay. So if a distribution company wants to meet its demand at any cost, it will bid higher price. This is price versus quantity. Here we have quantity. Similarly, the supplier, it wants to bid as low as possible so that it can be cleared. So these two curves intersect at this point. So this will be the market clearing price and this will be the market clearing volume. So this much quantity of generation load will be cleared in the market. This demand will not be cleared, so they will not be able to serve their need. But this was the only option for them. So this area is called as the social welfare, and we want to maximize this area whenever we do market clearing. Because why do we want to maximize this? Because suppose this is the market clearing price, correct? So this is the cleared volume for this demand. So if you maximize this area will be maximized. So this distribution company was ready to pay this much price, but it has to pay only a lower price. Suppose MCP is 5 rupees per kilowatt hour, and this he was ready to pay 10. And suppose this quantity is 100. So he has saved how much? 100 into 5, 500 rupees. Similarly with generator was ready to accept only 2 rupees, but he is getting 5. So its profit is increasing. So more the area under this between these two curves, more will be the benefit to both the consumers, both the discom and the generator. So that is why we want to maximize this area. This is what is social welfare. Then we have this minimization of both electricity cost and aggregators power consumption. Fourth is maximization of social welfare and minimization of aggregated power consumption. So these are the different types of objective which can be used to formulate the problem for the demand response analysis. Yeah, so this one was the correct answer. Now let us move to the another question. So this is the next question. Which of the following is a desired goal of an utility? So this also we have discussed. So can you answer this question? This is also easy question. Which one is a desired goal for an utility? So this means a peak load, a curve like this. This means curve like this. High peak deficit. That means this was a load, and suppose generation was this was the generation. So this is the peak deficit. We take the maximum one, this one. This is the peak deficit. And less off peak load. So these are the off peak load. So which one do you think is correct? Someone has answered. That is correct. So Jay, what do you think? What about Mohan? Mohan, what do you think? Which answer is correct? So we never want this type of cut. This means the installed capacity has to be much more than the average requirement. So we always want this. This is the ideal case. We cannot have this one, but still we have to minimize this gap as far as possible. So this cannot be the correct option. Then this is high peak deficit. If there will be a peak deficit, that is during the peak hour, if the generation is less than the load, then load curtailment will be there. And this also we don't want. So this is also not a correct option. Then less off-peak load. So if off-peak load is less in comparison to the peak load, then also this load factor will be high. This we don't want. This is a correct option. This is the ideal case which we are trying to achieve by employing different demand side management strategies. So now the next questions are on demand side management. So which of the following is correct with respect to demand side management? So first is load shifting demands. Load shifting demand side management strategy is more reliable compared to others. Then multi-objective strategy provides more peak load reduction. And third is demand side management using DC microgrid with BESS, battery energy storage, is an effective solution. Feed the peak load in existing distribution system. So which one is the correct option? So load shifting means if we have this kind of load curve, because our ideal aim is to achieve this curve. This option is correct, but is or are we can mix. Which of the following is or are correct? So there are multiple options which are correct. So just think carefully again. So A option is correct because we want this ideal curve to be like this. So what we can do, this area, we can shift it here and here. Yeah, C is also correct. That is true. What about B? So this is load shifting. We are shifting the load from peak hour to off peak hours, so that we can get at least close to ideal curve. Area under the curve is still same. We have just shifted the load. So this is load shifting. So option A is correct. Option C is also correct. Using BSS, so what will happen that on the DC side, storage is there because we want to reduce this peak load. If this peak load can be supplied by the energy storage, then this requirement will reduce. So the net load will become something like this. So we have reduced the peak load from here. So C is also correct. What about option B? So B is saying, so we discussed that there are two types of objective strategies for demand side management. One is single objective based and another is multi-objective based. So in single objective, we are trying to maximize the benefit to either utility or the consumer or load. But in multi-objective, we want to maximize the benefit to both the utility and the consumer. So in this case, both will be benefited. So answer D will be correct. That is true. The consumer wants its load to be maximized with minimum cost. So that can happen if it shifts its load to the off-peak hours because price will be less during off-peak hours, and utility wants to reduce the load during the peak hours. So both can be done. So this will reduce the peak demand. So this was also shown by some results in the lecture. So option D is correct. Now next question is, which of the following are the communication requirements for demand response? Quality of service, interoperability, scalability, flexibility, and security. So which one is the requirement? Here also it is or are. Mohan, yes, Mohan. What do you want to ask? You want to ask something? You can unmute yourself and ask. So which one is the correct option? Yes. Anyone? Answer E. Correct. Answer E is correct. So we want the communication to be secure. So it should not be prone to any kind of cyber attacks or any kind of missing data should not be there. Then the communication protocols and everything should be standardized so that we can have scalable solutions for big networks also. Then interoperability, different companies making different devices and they should be able to communicate with each other. Then also quality of service, it means congestion free. There should not be any congestion. No latency. So now the next question is, energy related demand response does which of the following things? So in demand response are of three types. One is price based, one is control based, one is load based. In load based we have two, one is task related and second one is the energy related. So here we are talking about this. So which option will be correct with respect to energy related? We just discussed few minutes back. Can you recall? Jay, can you recall? Alters both operation time and consumption. This is not correct. Yes, Jay.
B and C both.
How can both be correct? We discussed, right? Either of the two will be. In, in, in task related, one thing will be altered, and in energy related, another thing will be altered. So, how can we have both of them in single strategy? Think again. C alters the consumption during peak load. Correct. This is correct. So let me explain it again. This is confusing something. So I was saying that suppose this is a load. It coincides with the peak hour, and the energy consumption of this load is 10 kilowatt hour. So in energy related, what we are doing, we are not changing this area. We want consumption to be same, but the load is flexible to alter this demand which is occurring at this peak hour. So we can shift this demand to some other hour, any other period. Overall consumption in the entire day will still be 10 kilowatt hour, but the time of operation time will be different. So it alters the consumption. So it alters the operation time of the flexible load. In this option, there is a confusion. You are, in one sense, you are correct, Jay. I think I should change this option. See, this is creating confusion. Correct. So total consumption remain fixed, but the consumption time is adjusted. So actually, we can say this is also true and this is also true.
Yeah.
Correct.
I was thinking like.
Correct. I will change this.
So,
So if it is task related, so then because the operation time is fixed, consumption has to reduce.
yes.
So overall consumption also reduces in that case because it is not flexible to the time of operation. Because our main objective is to reduce the peak demand. So if the load is flexible, then it will still be able to consume the entire amount but at different times. But if it is not flexible, then it has to compromise with its consumption level. So I will change this option. Does not, you can say, does not alter. Okay. Now this next question is, which of the following is a dynamic pricing based demand response? So in price based there are two options. One is dynamic price based and another is incentive based. In dynamic price we discussed 4 types of pricing signal. So which one is incorrect here? This is not. What do you think?
Not means reactive time pricing.
Correct. Reactive time pricing is nothing. There is nothing, no concept like this. That was real time. So real here does not mean refer to this real or reactive PRQ. Real means real time.
Yeah.
Actual. So this we talked. There are 4 time of use pricing, then real time pricing, then what were the other 2? Peak load pricing and critical peak pricing. So these are the 4. So this is also a dynamic pricing based. This is also correct. This is also correct, but this is not correct. This should be real instead of reactive. Okay. So questions are over. So do you have any doubt in ECAT material or what we discussed today? You can ask.
A lot of doubts are clear. We have to go through again and again.
What about others? Mohan, do you have any doubt?
इसका इंटरफेस निकाल रहा हूँ उसमें लिस्ट रहता है फीडबैक लिस्ट.
So this presentation I have summarized all the 5 lectures. Everything has been summarized. So if you go through this, you can also, even the questions were such that everything is covered. So it will help in your exams also. So you can go through the slides. I will upload the slides just now, and recording will be available maybe tomorrow or day after tomorrow. Please, recording link slides. You can access it on the portal, and it is also available here. I will upload the slide in the Google Drive. So if you go to the portal of the course, on the left side bottom, you will find one option, problem solving session. In that, you will find the link for the Google Drive. In that Google Drive, there will be a link for presentation as well as the YouTube lectures. In the presentation, also have given the link for the recordings. You can refer this. Okay, so let us wind up then.
Yes. Thank you.
Thank you.
Nice direction. Yeah.
So thank you for joining. So we'll meet next week, same time.
Thank you, sir. Thank you. Thank you, sir.
Thank you.